Okay, I'm gonna do this problem from class. I don't think I actually did this one on the board, but it was one of your in-class problems. Number 2, we have this circuit's given, and we're supposed to find a Thevenin equivalent circuit, which should look something like this. Remember, to solve a Thevenin problem, we always need to find 3 things, and the 3 things we need to find are: we need to find the Thevenin voltage, which will be equal to the open circuit voltage. In other words, if we were to find this voltage right here, that's going to equal our Thevenin voltage. The second thing we need to find is the Thevenin resistance, which is the same as my equivalent resistance. And the third thing I can find is my short circuit current, which is the current that would flow across this if I were to connect these 2 wires. So if I was to connect these 2 wires, then there would be a current flowing here, and then I would call that my short circuit current. So the thing about solving these Thevenin problems is you really can, it doesn't matter which you pick to find. We need to do 2 out of 3, because once we know any 2 out of these 3, then we can just do Ohm's law to know that VTH is equal to ISC RTH. So again, we only need to find any 2 out of these 3. So we just pick the 2 that are easiest. Almost always, the easiest thing to find will be the equivalent resistance. So I think I'm just going to do that one first. And to do that, you just zero out the sources. Current sources basically become open circuit, so this just completely goes away. If I had a voltage source, it would just become a short circuit, which would be a wire. So let's do that one first. Let's find RTH, which is equal to the equivalent resistance. And again, remember, when I mean by equivalent resistance, it's equivalent as perceived by the 2 open circuit terminals. So basically I have to simplify this whole thing into an equivalent resistor. Okay, basically the current source goes away, so I end up with my 2 resistors basically in series, right? This is where my current source was, but that becomes an open circuit, so it completely goes away. And I basically just end up with my R1 here, which is 10 ohms, and my R2 here, which is 40 ohms. So my equivalent resistor, which happens to be my Thevenin resistor, is R1 plus R2, which in this case would be 50 ohms. So I just found my Thevenin resistor. Alright, that was pretty easy. Alright, so let's go back to the beginning, to the original circuit. Every time that you're done and you need to go to the next one, you have to go back to the original circuit and decide what you want to do next. So the question here is, what's easiest? Is it easier to just find the voltage across these 2, or is it easier to short these 2 with a wire and figure out what current wants to flow through? I'm going to think here that finding the voltage will be easier, because if you think about this, if you're trying to find the voltage across these terminals, this entire thing over here is just a loose appendage that goes nowhere. So this actually has this resistor would have no current going through it, assuming that there's no wire here. This resistor goes nowhere. So basically this voltage is really the same as this voltage, right? Because we would just wipe this completely out. So let's do that one. So let's find the voltage, which is equal to the open loop voltage. So again, like I said, since there's no current going through this, the voltage across this, I basically can just redraw the circuit, not even draw this resistor, because this resistor has nothing going through it, and just find the voltage across these 2 terminals, right? So basically, in this particular circuit, VOC ends up being the same voltage across R1, right? Because no current flows through R2. And also, since no current flows through R2, all the current generated by the source has to go through R1. So this actually becomes really easy, right? The voltage across R1 is just V equals IR. So VR1 is equal to the source times R1 in this particular case, right? Which is 5 amps times 10 ohms. So that is 50 amps, right? So that's my open circuit voltage, which by definition is my Thevenin voltage. So that tells me that my Thevenin equivalent voltage, did I say amps? I meant to say volts, obviously. So Thevenin voltage is 50 volts, and that's it. I'm pretty much done. And then I can find my short circuit current if I want. That is the Thevenin voltage divided by my Thevenin resistor, and that would be 50 volts divided by 50 ohms, which is 1 amp. All right, and then draw the equivalent. You end up with a voltage source in series with, can you guys hear that thunder? In series with the Thevenin voltage of 50 volts, Thevenin resistor of 50 ohms. Now, same thing, I could actually at this point, and I don't have to anymore because like I said, you only need 2 out of the 3, but I could just find that current ISC. If I put a wire right through here, then I actually end up with, like I said earlier, I end up with this circuit, and I can solve that circuit in a number of ways to figure out what this current would be. And if I do that, I'm going to come up with also this very same number, 1 amp, right? So you can find all 3 things independently, though all you really need to do is find any 2 out of these 3 and then find the third one that way. Okay, hope it helps. See you later.